Hello there, welcome to a programming live session for Evaluate Programming Language. Today we're going to be working on the Interpreter version 2 because it's something that still needs to be done, so I thought it would be good to do it live here. This event is also running in the Programming Live voice chat in the Discord server, so you can go there if you want. If anyone watching this, which I don't think there is right now, but if you're watching this live, then you can go into there, and if you want to say something, then say it there. I'm also sharing my screen there, but for now, let's get started. First, I'm going to take you around evaluate.js so you know what's here. So firstly, so you can check the streams alright. Streams good. So this is the index.js file, and essentially what this does is it's a start file. So you see, first I have to make sure that Unix-based systems know that this is a Node.js file, because this is also a command line interface. So and then it gets all the language stuff. Then it clears the memory, and then it gets the programming arguments, and then if the program doesn't exist, then it exits. So the first thing it does is it goes through the lexer. The lexer tokenizes the program and makes the program into a list of valid characters that the parser can understand. For example, if I put my program as 1 plus 1, the tokens would be 1 plus and then 1. So then the parser takes those tokens and generates an abstract syntax tree with them. The abstract syntax tree is basically a list of all the items in the program and instructions for the interpreter to carry out. Then obviously the interpreter carries out the instructions and then returns the answer and then returns the values. Today we might be working on interpreter v2 because my current one's not that smart, so yeah. But I might not. I'm still deciding what I'm going to do. But let's show you the Trello now, which is essentially my to-do list. So as you can see here, I've got a bunch of stuff to do. For example, I need to put brackets onto the tree, I need to do expressions, and I need order operations. Just general things that a mathematical programming language should have. And I've also got some stuff that's done, for example, basic blocks, test suites, integrated errors, and binaries, and byte space sensitivity. If you want to join the beta program for the programming language, then please join our Discord server and you can take part in the focus test. So yeah. Now let's go back to see what we're going to do. So today, I'm just going to go through everything. So in the lexer, so I've given you a summary of what happens, but in the lexer, I have a bunch of fake enums. Then I have a list of negatives, which are basically in my programming language, a list of characters which split lexemes. So any of these will split numbers and words essentially. So if we're getting something called memory, and so that it doesn't get confused with other stuff, then these will split it just like how it says. This is just a general regex, and then we put the end of file character. It's the Alexa splits the script into new lines, creates a list of items, then it pushes an EOF character onto the end of it, and then for each line, I split the characters with the negatives. So I'll take you through that later. And then for each character, I check if it's a number or if it's 0. And because like 0 is also false and like just a faulty value, so I also check if the character is not quotes. I could probably actually first of all programming that should work hopefully. Just gonna keep the other side, but that should work now. And next, I check if it's not a character, so if it's like undefined or something, which generally happens with my regex for some reason. I'm not too sure, but it just works if I just return all the undefined values. And then I use like lots of logic to find out what the character is. So if it's a space, or which it shouldn't be, but if it is, then I just return. And then for like all the different types of blocks, so brackets, curly brackets, and square brackets, I put all that into the items list. Then for each of the operations, I put the operations onto the item list. Not too sure why those are there, but yeah. I'm not even sure why this is here again, but like I said, all this needs to be rewritten at some point because it's flash codes. But yeah, I don't know why this is here. Like I've got no use for this, so I'm just gonna go ahead and remove it. And now we got on to memory. So like memory is one of the most complicated parts of this, because I actually use JSON to store the memory, and with just the Node.js default file system module. So the set memory, use the msec keyword, so like var, because I want to make this interesting. Not the best, but that works. And then finds the character and then idents as memory set, I then categorize it memory. And the memory clear, I haven't set that up yet, but that's something to do later. And then anything else is just reading memory. And yeah, but that can be changed in the parser, which it does get some other ones. Then at the end, I put an end of file character so that in like operations or stuff, I can check if the next character is a number, if it's an end of file, or if it's a word. Because if it's not a number, then I throw an error. And I just export the Alexa. Now the parser. Like I said, the parser. What the parser does is it takes the tokens from Alexa and creates an abstract syntax tree from that. I'll talk about ASC later, but for now, this is just what it does. And yeah, so I actually built this off an old project that I made called Complicated Calculator, but that was written in TypeScript, so I made it evaluate from it. And then yeah, so this is the parse function. Sorry, my computer's lagging quite a bit. So the parse function, as I said, it takes tokens, creates like a bunch of values, so it knows if like it's in a bracket or something. And then for each of the tokens, it reads the element, and if the element is red, each of the elements also have a property called red, which basically means if the parser's already read it, then it won't do it again. That's useful for like memory where you have to skip some. But I'll get to that when we get to that section. So first thing, it looks for any end of file characters, and here, this basically checks if it's inside the program, and so at the end of the program, if a block is still open, then it will throw an error. But if not, then it will say that the next token will be the end of program, and then it will push an EOF character onto the tree. Now we have new line values, which in the programming language are strangely identified with a semicolon. So I think one of the worst things about my programming language design is that if you put a semicolon anywhere in the program, that will automatically be a new line. So it makes debugging very difficult because you might accidentally put a semicolon in, and all the errors in the program look for the semicolons and see which line it's in depending on the semicolons. But that's something that's going to be updated in future updates. So yeah, it pushes a new line. Sorry. Yeah. So it pushes a new line character onto the tree with the semicolon, and then it will increment line by 1 so that the parser knows which line it's on. So if it's an open bracket, an open curly bracket, it will be a case 7. So it makes the token red. Then it increments current by 1 so that the parser knows which token we're on. And then if the block's already open, then it throws an error equation open, because another thing with my programming language is it does not support nested blocks. And then it pushes an open block onto the tree. Then it returns block is true, so that the rest of the program knows. So 8 is literally the opposite of that. And then 14 and 15 is the same things but with brackets. And 16 and 17 is the same thing but with square brackets. So cases 2, 3, 4, and 5 are operations. So mathematical operations. So plus, minus, divide, and multiply and divide. And then if it's a number, so ident 0, then it will push number with the float number. Then if it is 11, which is memory, so that would be var, so get memory, essentially. So yeah, it puts value tokens and then declarations. So whenever I'm doing stuff with memory, I always include a declarations field in the body item, because that shows the interpreter what it is that it's looking for. So here the ID of what it's looking for is token is the child current token, and then it returns current by. Oh, that's a bug. That's not meant to happen, but anyway. Okay, so now next one, if element is 10, which is mset, so setting memory, then it will set the current token to red, and we'll set the next token to red, and it will set the token 2 times to red. That's because my memory settings syntax is different to other languages, because my syntax, you have to put mset, no equal sign. So mset variable name to variable details. And the reason why I put it like that is because this was built from Complicated Calculator, which was my very old which was a very old project in TypeScript, as I've already said, and that was meant to be a calculator as a programming language. So and I don't really know why, but that's just the syntax I came with. And then again, declarations from memory. If I go back there, I'm just gonna check that the stream's okay. Yeah, the stream's okay. So in declarations, you have the ID, which name is tokens current, which the ID is the second token on the list. So because JavaScript indexes from 0, that's 1, so current plus 1. I was going to say mset A12, then that would be A for the ID, and then init is the value that it applies to the ID, so that would be 12. Because I said mset A12, because that's current plus 2. Then the value is just mset tokens 1 and 2. That's generally just for personal formatting, because the computer can't understand that. Then I increment comment by 3. Then if nothing happened, then I increment comment by 1 anyway. So yep, here I have the abstract syntax tree. So type is program. Tokens is tokens. The length of all the tokens is tokens.length. And the body, we've already made the body, so that's that. Then just returns the AST. And now we're going to look into the interpreter. Now this interpreter is really bad. I made this interpreter a long time ago. I haven't really touched it since Complicated Calculator. But I have tried to edit it a bit for what I need. And yeah, it really isn't the best, but it works at least. Which is why I'm going to be making Interpreter 2, which will be able to support big mass and expressions. Because that's something that doesn't happen here. Whenever you do something, it just prints out the answer instead of returning it. Could be like a proper language feature, but I don't think it's the best. But it could be. I will do some work on the interpreter today, hopefully, on this live stream. So that's fine. And so yeah, so new line just increments current and then increments line, because the interpreter has its own line dealing stuff with errors. And then for each of the brackets, I have currently no clue how to add these in interpreter v1, so it just returns the command. They don't actually do anything for now. It just increments current, but that's all. And then for memory, this is probably the part that I touched the most in the interpreter, because Complicated Calculator didn't really have a memory. So here I go. But if it's mset, then increments current by 1, and then it pushes data with the ID and the init, and then it returns arms equals element declarations dot init dot value. So I'm just going to change this. Because why not? That's good. And then with and then we have get memory, which is the var type. So it gets the ID from the tree, and then it finds the memory, then takes it to string, then it passes the memory because it's all in JSON, and then it finds the answer as data ID. Then if it's not arms and arms is not 0, so if it's not a number, then arms equals data ID, because that just gets like the word. And then if it's still not arms, meaning that it's undefined, then I throw an error not defined, what ID is not defined in memory. With each of the errors, I put a line as well. So then I increment current, and then I return. For operations, yeah, same thing. Of course, interpreter 1 doesn't include big maths, so interpreter 2, but simple maths. Also, no modulo. Like, I forgot to put a modulo in here, but something to do next. Yeah, so comment +1. If nothing happens, then it exports interpret. So that's all good and all, but now let's see a proper demonstration. So first, let's run my test suite. I go into the terminal, and I write npm test. Hopefully this will work. So my computer's really slow. I don't know why, but it just is today.